Now we have discussed about the solar collectors. So normally the solar collector is a device for collecting the solar radiation and transfer the energy to a fluid passing in contact with it. So utilization of solar energy requires for a solar collector to observe the to collect the energy. So required for the solar collectors. So generally there are the two type of solar collectors we are using. The first one is a concentrating or a focusing type of collectors, and second one for the non-concentrating or flat type solar collectors. The solar energy collectors with associated with the observer is essentially compound of any system for the conversion of solar radiation energy into more unstable of like as a usable form of heat or electricity. In the non-concentration type of solar collectors, the collecting area like as a area is intersect of solar concentration type radiation in the same observer area. On the other hand, or other type of other hand, the concentrating collectors, the area intercepting in the solar radiation is a greater compared with flat plate collectors. So by the means of concentrating collectors, much higher temperature can be obtained than the non-concentrating type, like as a flat plate collectors. So the concentrating collectors may be used to generate medium pressure of steam. They use many different arrangement of mirrors and lens to concentrate in the sun rays to the onion boilers. So this is the better efficiency compared to the flat type collectors. So compared to the flat plate collectors, the best efficiency of collector should be mounted on the face sun moves through the sky orientation. So the flat plate collector maximum temperature to be attained as a 90 degree Celsius temperatures. So these are basic things of solar collectors. So next for that, before we going to the collectors, that is a basic principles of conversion of solar radiation into a heat energy. So that is a fundamental process. In generally, we are used as a heat conversion in a greenhouse effect. This is the name as a name come from the first issues. This is a greenhouse effect. It's a possible to grow the plant into climatic through a better utilization of available from the sunlight. So the most of the energy we receive from the sun comes in the form of light, that is a short wave radiation, not all for visible to the human eyes. So when the radiation strike the solids or liquid, it is observed that transfer into a heat energy. It become a warm and store the energy, or otherwise a heat to contact the surrounding material, like as a air or waters or other solid or other liquid material. So it is a other material for low temperatures. So the re-radiation is a long wave radiation. So the from this figures shows that what is that means. That is a figure shows here from the figure shows the how temperature on the earth is affected in a greenhouse effect, visible effect. The visible sunlight is absorbed on a earth surface, that is a visible absorbed from the earth surface or ground at a temperature of 25 degrees Celsius. For example, that is a infrared light wavelength is about a 10 micrometer, but the CO2 atmosphere absorb the light, the wavelength and back radiation a part of the earth, it will be scattered, that is a CO2 is scattered. The atmosphere, the black light of CO2 does not absorb the incoming of sunlight, which has a shorter wavelength. Generally, that is a glass easily transmitted a short wave radiation, which means as a like as a infrared to the incoming solar energy, but it's a very poor transmitter for long wave radiation. When the sun energies has passed through a glass windows or otherwise absorbed some of the material inside the rooms, and the heat will not be radiant to back outside. So the glass, therefore, heat trapped, that is a phenomena which has been recognized the construction of greenhouses, which can get quite warm, certain even in middle winter, that have a known as a fat of greenhouses, right? The solar connector has become as a usually called as a flat plate collector. So almost have some more glasses covers with plastic or transparent material are often used instead of glass. So here in this figure shows black painted plate is observed. That is a black painted plate is observed. Observer, like as observer. Incoming of sunlight is observed. A fixed plate is ordinary window glass. When the temperature of black plate increases, emit increment of thermal energy from the infrared light. So that is a black observer has a property. That is a black observer has a property. Black body. So black body. Ideal body have not only highest absorption rate, but also has highest emission coefficient for all the wavelength light. So the emission is increases. That is the infrared emissions. So emission is increases with the temperature. Temperatures. So the re-emit of light if so progressively shorter wavelength at greater energy as the temperature of black body increases with the increases. So that is a Williams law is also expressed, that is a term T constant or temperature is constant. That's a unit is 2009-89 micrometer Kelvin, like as a micrometer Kelvin we have says, that is a micrometer Kelvin. So now we have discussed about the characteristics of collectors. The solar collector system include the following characteristics. That is a type of solar collectors. So whether that we are using as a focusing collector or non-focusing collectors. Then the temperature of the working fluid. So the temperature of working fluid such as three different kind of temperature we have used. That is a low temperatures and medium temperature and high temperatures. That's the temperature should be chosen. Next one is the tracking system. So whether the tracking system is used or not. Suppose we are used means that is what type of tracking system can be used, and tracking type or non-tracking type, and tracking as a one plane or two planes to be decided. So next one is the cost of collectors. The cost of the collector system has a low cost or a high cost to be decided. So next one is the design and design of the solar collectors. So design of the solar collector system such as simple method, simplest structures or complex structure of the design to be identified. So next one is the layout of solar field. That's a solar field and configure the solar collectors in a solar field. There is a layout. Layout means that is a solar area. Likewise, that is a cost wise to be select for the layout of the solar field. This is some of the characteristics of the solar collectors. So next one is that performance incidence of the solar thermal collectors. So the performance incidence of the generally the sunlight has a low density, so such as a 0.1 kilowatt per meter square to 1 kilowatt per meter square. Hence a very large surface area of the collector is required to producing a rate of power is required for up to 1 megawatt. So the performance of instance indices of solar thermal collector system has to be mentioned here. So the first one is a concentration ratio. So the concentration ratio means that is a ratio is defined as area of aperture of the system to area of receiver. So that is the aperture of the system is projected the area of the collector facing of the normal radiation. The flat plate collector have the concentration ratio equal to 1. So if the focusing collectors mean that is a concentration ratio will be varied. That is it's not as a unity, it may be more than 1. So that is a temperature ranges. So the temperature range means the temperature range is which should be heat transfer the fluid is heated up to the collectors. So the resulting temperature of the heat transfer fluid of solar collectors, heat transfer of the solar collectors attain a higher temperature concentration ratio of in order of 1000, attain it may be 1000. It can be obtained. The heliostat with an sun tracking of two planes. So the concentration ratio up to 100 can be achieved with the parabolic trough collectors with sun tracking of one plane. So it will be increase the temperature ranges mean increases mean number of collector to be, that is increases by the number of collector to be connected with a series or parallel system. So next one is a absorption or a reflection ratio. It has the effect of temperature is attained by a heat transfer fluid. So the absorption or reflection ratio or the range is 1 to 40. That is it may be 1 to 40. So last one is the collector efficiency. That is last one is the collector efficiency. The performance of collector is to be analysis in the term of collector efficiency. So the collector efficiency is defined the ratio of energy actually absorbed and transferred to the heat transferred by the fluid by the collectors, and the energy of incident to the collectors, that is energy collected by the, that is the ratio of energy collected by collectors and energy incident on the collectors, that is the collector efficiency. For the rate of collector, for the rate of solar insolation, the collector efficiency decreases with increasing the increasing difference between the collector temperatures and outside temperatures. That is efficiency is based on the collector temperature is outside, that is outside atmospheric temperature, like I said, atmospheric temperature, collector ratio of the collector temperature to atmospheric temperatures. Next we have discussed on that factors affecting the solar collector system. So what are the factors means? That is efficiency of the collector system is adversely affected by the shadow, cosine losses factors, and dust, etc. This aspect of influence of the design of the collector ratio. So the first one is a shadow effect. Some of the neighboring collectors panel shadow fall on the surface of the collector, particularly when the angle of evaluation on less than 15 degree. The shadow effect is reduced the angle of evaluation of sun increases. The shadow factor is the given means, that is the ratio surface of the collector receiving light to total surface of the collectors. So the shadow factors is less than 0.1 for angle of evaluation less than 15 degree. So it is 1 during moon while the sun is nearly 90 degree to the collectors. So the cosine loss factors. So the cosine loss factors means as I started earlier, that is a solar collector surface receives the maximum radiation when the sun rays fall perpendicular to it. So it will be considered as a theta, and that is angle is theta between the direction of sun rays and plane perpendicular to the collector surface. The area of sunbeam interacted by the collector surface is proportional to cos theta. So therefore the solar power collector is proportional to cos theta. For the fixed type of collector panels, cosine losses varies due to the vary of daily variation or seasonal variation of the sun rays. So next one is reflecting loss factors. So with the passage of time, the collector glass surface and reflector surface collected dust or moisture or grit, hence it has get it rusted, deformed, and loosen the sunshine. So hence the efficiency of the collector is significantly reduced. It can be produced, it can be prevented by the proper maintenance carried out. So time to time it can be reduced of the reflective loss factors. So the sum of the factors to be affects by the solar collector system, that is a shadow effect and a cosine loss factors and reflective factors.